So you're happy with the topology, happy with what we talked about with the customers and what the requirement is. Piotr, where do I start with my multicast across this network?
Definitely, we should first of all prepare the core network, so the MPLS domain.
Okay.
Do we need, because there are several considerations. First of all, we can consider, do we need to send multicast as a labeled multicast or unlabeled multicast? Because still, even if we have MPLS domain, we can still send multicast as an IP packet.
Okay.
It's not determined yet because we have several MVPN profiles, and one of them is using MGRE. So for unicast, layer 3 VPN, we will use MPLS automatically by configuring multi-protocol BGP layer 3 VPN.
Yeah.
And still we can have multicast sent by IP encapsulation. If we prefer, of course, one or consolidated, unified paradigm of sending both multicast and unicast is preferred in my eyes because we avoid duplication of policies, duplication of QoS policies.
Yeah.
We can concentrate, we can focus on the same, let's say, shift transferred packets. We can focus on the same fast convergence mechanisms based on MPLS, IPLFA, which is also related to MPLS LFA. I mean, to labeled packets or point-to-multipoint traffic engineering tunnels. So let's stick to the MPLS, and then
sounds good.
With
sorry, just before you carry on there. So from when I was all those years ago, when I was studying for my CCDE and looking at the service provider technologies, I remember the multicast GRE thing. Is it Rosendraft? Is that?
Yes,
right,
that's the Rosendraft.
And certainly from I think that's probably is that fair to say that's the best known approach to delivering multicast across?
I think still is the best known approach, although since several years right now, labeled multicast is well implemented. I mean, we already passed the stage where it might be not properly implemented, or there are several bugs in the implementation.
Right.
Juniper and Cisco specifically started from different approaches. So Cisco started from MLDP, whereas Juniper started from point-to-multipoint traffic engineering tunnels. But actually, today, both vendors support both approaches, so you can configure interoperability. So I would say since 4, 5, 8 years right now, you can use MVPN with the success without worrying too much about the commands or worrying too much about features or bugs. So yeah, I would say in the enterprise area, labeled multicast is not existent, or in, let's say, in small, medium enterprises, of course, because for big enterprises, they have their own also core networks, and MPLS might be there as well. But yeah, to make the answer short, Rosendraft is the most popular, but labeled delivery of the multicast has its own benefit, and I would say
Yeah, so I think what we're saying is, like, you know, if this was, for example, if this was a greenfield site that was being designed from scratch, you'd really want to probably, you'd probably want to like go with, based on what Piotr has just mentioned about supportability in various platforms and feature parity and things like that, you know, labelled is probably the way to go. That said, even though that might be a recommendation, there's always a case of that might take some influencing, because the MGRE approach and the draft Rosen approach might be seen as, we've got a problem, we need to solve it, we've got a sticky plaster solution, so let's use it, and then it'll work.
Again,
you know? So it'll do the job.
Standard thing, right? Yeah.
So is there any like the other thing I always want to call out, because that the fact that was GRE based blew my head when I was studying in my CCDE. I was like, what? How can it be GRE? It's not like MVPN. I had all of the GRE aspect of it is dynamic. So we're not going to deep dive into configuration, but it's just something worth calling out, that when people hear about this for the first time, or maybe it was just me, I don't know, it's easy to think, oh, GRE, or all the traditional things that you know, nailing up GRE tunnels and things like that, that all happens under the hood of the, you know, of the configuration. So it's probably worth just calling that out.
I mean, I guess there's also an MTU question wrapped around that as well. Is there?
Yeah, that's the very valid point. For MPLS transport, the MTU overhead is much smaller comparing to MGRE.
Yeah. So there's plenty of pros and cons and things to be concerned about there. But I like the fact, what you're saying, Piotr, about the fact that you're using the same mechanisms for unicast and multicast. That appeals to my sense of natural order, really. I suppose that you've got one mechanism for delivering traffic, whether it's multicast or unicast, and it's label switched basically. And that's cleaner for me. I like that.
Yeah, the only comment from operational perspective is that if somebody used already for years PIM multicast in the global routing table without labels, then moving towards labeled multicast, it means that you need to learn something new, either MLDP or BGP signaling or other methods of providing multicast through VRF and through the labeled transport, which is different comparing to MGRE. With MGRE, you are providing overlay multicast distribution tree using the same mechanisms, PIM, sparse mode, PIM, SSM in the core, as well as in the customer overlay. Whereas in labeled transport, you have different approaches for the core, and let's say the standard approach for customer overlay.
Right. Okay. I'm with you. Yeah. So there is that difference. So I suppose from a support perspective, you've got to consider that MPLS network as being a separate network and having different mechanisms for delivering the traffic and understanding the boundaries between the two, which is one of the points that mentioned in the agenda, I suppose, isn't it? Is that right? Okay, we have customer networks behave like this. We have the service provider network, the MPLS network, that behaves like that, and there's a translation between the two and a process you have to go through to get from one to the other and back again. So yeah, understood.
Yeah, of course, in MGRE solution, core network is separated from the access layers because VRFs are configured, but you can use the same approach for control plane configuration in both core network and customer overlay in MGRE. Whereas in MPLS, you have to use different approach, either MLDP or point-to-multipoint traffic engineering, ingress replication, or some different solutions.
Cool. Okay.
Yeah, I was just gonna round that, so that MGRE versus LDP. There was one specific point there that I wanted to, and again, not delving too deep into or really at all into configuration, right? But let's say MGRE most of the configuration is done on the PE, but we obviously need to enable multicast on the P nodes, right? And keep me honest here. So if we then, so very little configuration on the P nodes, and because obviously like the MGRE Rosen model goes over the top of the P nodes effectively between PEs. When we move to an MLDP model, does that change much in regard to how much effort there is to maintain the P nodes, or does it just depend on the scenario and what the use case is? Because obviously there's point to multi-point and multi-point to point, multi-point to multi-point, and break points and things like that in the middle of the network that you could potentially use, which differs slightly where the P nodes could potentially be used more in comparison to Rosen. So what's the impact of moving it to LDP versus GRE based, from a support perspective, and what you need to support where?
Yeah, from my perspective, with MLDP, for example, you can have less effort creating a MVPN solution based on MLDP comparing to MGRE. Why? Because MLDP can be used for both, for the core network, multicast distribution tree, and as a protocol to transfer PIM messages from the customer overlay from the edge PE to the other edge PE. And you don't need other protocols for that, just MLDP. Of course, you can use MLDP plus BGP or MLDP plus something PIM protocol, but with MLDP alone is enough to provide both core signaling and customer overlay signaling for multicast. So it depends, of course. MGRE can be simpler as well if we use PIM SSM in the core and PIM SSM in this customer overlay. It will be simpler solution in my opinion than, for example, MLDP plus BGP auto discovery plus BGP signaling. But every solution has its own trade-off. So I would say every profile out of 27 profiles of MVPN right now available has its own, perspective and some even single use cases. But that's the good point. That's the good point that which also comes to my mind, and you Malcolm mentioned that with MGRE you can also let's say get rid of obstacles in terms of aggregation or summarization in the core. Whereas with labeled multicast or labeled traffic, you need to have continuous label switched path. So you cannot have aggregation in the core. Of course, in the core, we shouldn't have the aggregation points or edges, but still that's the also checkmark we should do before implementing MPLS for multicast.
Excellent. All right, cool. Well, I think that was a brilliant sort of intro and setting the scene on the couple of different techniques that we've got that can obviously branch out into lots of different sub techniques. But we're probably at the stage now where, Daren, let's get some freestyling going on, and over to you, draw some stuff, man.
Well, I think I might need to draw into Piotr on this one, because it's now, I suppose, working out how we're going to do it in this scenario. So Piotr, you've already mentioned the MLDP is an approach for this. I think we're happy with that. Where does it go? What does it do? How does it make this happen? If we've got our I'll just draw our sources and our destinations back in. How does our source, which lives up here, I hope you can see that little green blob now. hit our digital signage down here now. That's not, yeah, there we go. Down in these guys. That's just cleared. That's just cleared on my screen.
No worries.
But we'll bring it back. That's all good.
Just draw it in again. Persistence pays off.
Something like that. Okay. So yes, so how does if we have a digital signage server set up in the data center block up here, how do we get that guy multicasting down to our digital signs which live down in Fairyland, down in Monsterland, down in Vampireland? You know, we've got a multicast group that this guy is sending out to let's say 239.1. This is, come on, it's not wanting to draw for me today, but never mind. 1.1.1. Okay, how do my guys digital signs down the bottom join that same group, and how do we get that continuity all the way through? What's the approach we should be taking?
Yes, so we can have at the top of decision tree, please keep in mind that we have two solutions: layer 3 VPN, I mean MVPN, based on routing, based on core distribution tree and customer distribution tree. But we have also layer 2 VPN. So in this specific case, more PE devices we have, the more reluctant I would be to use layer 2 VPN. But why I'm thinking about layer 2 VPN, even though we should discuss just MVPN, because from PE devices down to access devices, we have layer 2. So actually we can have also either multiple of pseudo wires coming from devices to the data center, and that's it. That's the also viable solution, because we don't need to take care of core distribution tree in the MPLS domain.
So what you're saying there is basically across that MPLS network have pseudo wires that extending layer 2 across here, yeah?
Yeah, so those pseudo wires are coming.
I'm just going to delete. Okay, go for it.
So we can have ask for annotate.
Go for it.
All right. So at PE devices, we will have bridge domains. So bridge, hold on, and bridge domains, and then we will provide, as you start drawing pseudo wires from data center PE to the leaf or some PE located in the lands. And in the data center, we will have in this way bridge domain, which is accumulating or terminating those pseudo wires.
Right.
We can, of course, provide hot standby pseudo wires to provide active standby switchover for fast resiliency and to provide simply connectivity in layer 2. So that's also kind of solution you can use. Depending
just to clarify, so we would just use IGMP over the layer 2 in that scenario.
And that's the trade-off, that we are building one broadcasting domain. And of course, we can, let's say, turn on IGMP snooping. We can try to control flooding for broadcast and non-unicast and multicast, but layer 2 is imposing much higher risk for stability, and it's providing phase sharing between data center and other LANs. So from the perspective of scalability, from the perspective of stability, resiliency, layer 2 solutions should be avoided at any cost.
Yeah. And that feeds back into, Malcolm, all those design discussions we've had before about our design principles, right? Is exactly that. It's that this is the whole point of chopping the network up into blocks, is that you don't have one block affecting another block and so on, right? So yeah, agree with you completely on that one, Piotr. The layer 2, oh gosh, that old chestnut, isn't it, of extending layer 2 everywhere is like, just please.
Yeah,
if you can avoid it, then that's fantastic.
Yeah, I recommend for anybody who is using layer 2 to terminate the pseudo wires at the customer side with routers, and that will be excellent. But otherwise, you can create very high risk, because nobody can guarantee you that you don't have a layer 2 link between LANs. If you have such a link, backdoor link, you can end up in a permanent loop, and that's the end of our solution.
That's the end of someone's job, isn't it? It boils down to it. But yeah, no, good point well made. But yeah, right. So having ruled out that solution, then
let's rule out the solution.
Let's rule that one out.
That one is not a network freestyle validation.
Yeah, no, we don't.
But it is an option. Like,
no, it's an option. You can see there is a use case. There is a use case where that, and as Piotr says, you put a layer 3 device on the end of it, and at least you're then using it as is effectively a point-to-point path over that layer 2. That layer 2 adjacency, isn't it, effectively, that you're forming across that layer 3 network?
Yeah, in that way you can somehow translate any broadcast multicast into the unicast path in the core. But
we don't want to do that. We
want MVPN, which is proper solution, sophisticated enough that you can provide job security for yourself.
You're talking my language, Piotr. Sophistication is I'm all about sophistication. Hence the T-shirt.
Always trade-off between sophistication, complexity in some solutions, but it depends on the learning curve. If you train in that matter, if you spend enough time with multicast is not as simple as unicast, of course, but it can be tamed. It can be understood properly, so you are providing correct solutions.
Not as simple, but could be simplified. There you go.
That's the very good.
I think one of the things that I tend to sort of push towards is getting people to understand things to a level where they can automate them. Because if you can do that, then you can cookie cutter things and whatever. It becomes simpler to deploy, even though it's not necessarily a simple solution under the hood. At least you've got that ability to sort of say, right, okay, this is how we do it. We set a standard, we define a principle. This is how we do it. People have to learn how to support it, yes, but once they've learned it, it's the same wherever they go across their network. And I think that's what this needs to be for me.
Yeah, so we can move on to MVPN.
Cool.
So what we need for MVPN? Well, I mentioned to configure first the domain, and let's focus on that. So we need to configure, of course, either LDP. It's showing somehow All right. Let's consider that that's the LDP. LDP is the same protocol which is supporting unicast and multicast.
Right. So I was just going to say LDP will already be running in the network, let's say, because you're running layer 3 VPN over the MPLS, so you're already running LDP for that purpose.
Yes.
Is there any different that you need to do for multicast LDP? I don't know.
Of course, you need to configure the tunnel endpoints. I mean, not the tunnel, because there is no proper tunnel, but the root of IP address of the root of point-to-multipoint distribution tree,
Right.
or multi-point to multi-point distribution tree, because what LDP or MLDP is doing for multicast is that it will compose the distribution trees for the core network, and there are two distribution trees, point to multi-point or multi-point to multi-point. If we have many sources like here, actually sources from the core perspective are PE devices, all right? So PE devices we are building a distribution tree from the PE standpoint. And if we have one way of flowing the data, point to multi-point distribution tree might be, let's say, enough good approach, all right, to compose this distribution tree. If we have, let's say, collaborative application, we have communication in both ways, any to any, multi-point to multi-point distribution tree might be a better approach. Please also note that we tried to the MLDP, but keep in mind that as a core protocol, you can also use MPLS traffic engineering. All right, so you need to build MPLS traffic engineering tunnels for multicast. So those tunnels are point to multipoint tunnels. There are no multipoint to multipoint MPLS traffic engineering tunnels. And you can also use gear or ingress replication. All right, so there are four methods for building multicast distribution tree for the core domain. Right, but I would suggest to go for LDP or MLDP in this manner, and then we need to add or define the IP address of this for this multicast distribution tree on each of the PE devices. Then LDP will build distribution trees. We need to configure then the edge of, the edge devices towards the customer. All right, so then we can move on to VRFs and PIM protocol, which has to be configured on VRF devices, on VRF interfaces. One more point for the core network is BGP. Do we need to use BGP or not? It depends on us, because as I mentioned, we can map customer overlay signaling to MLDP updates. So LDP will be responsible for sending mapped signaling from the PIM protocol, from PECE links through the core network. But BGP has also its own advantages, and we can benefit out of them. So, for example, auto discovery is one of them. So we can discover active PE devices which are having the VRFs actively participating in the multicast, either sending the multicast or receiving multicast. And also we can use BGP to better or scale up to much higher number of groups, to scale up to higher number of VPNs. We can also compose a much more complicated situations for inter-area multicast distribution with BGP, not LDP, of course. So BGP approach establishing the control plane has, of course, its own value. We also need to remember of controllability. I mean, with BGP, we can set up attributes. We can set local preference and weights, which PE is preferred from the receiver standpoint.
So you're basically using BGP in the way that you would use for unicast. You've got that control and the policy really that you're driving it through the network. You're able to use the same policy controls, but for multicast traffic.
Yes, correct.
Is this achieved by it's basically an additional address family in BGP? So that's where some of the flexibility comes in, I guess, that it's address family, MVPN or whatever, and then you nail up your neighbours, or if it's a route reflect. Well, that's actually a question. Can you use BGP route reflectors with this as well?
Yeah, BGP route reflector is just for reflecting the routes.
So I was going to say, so you're already using you're already using BGP. You're already using address families for the layer 3 unicast VPN stuff. So really, you're just using the same mechanisms that are already there. So you're also delivering your multicast, right? So
Exactly. It's enough to add additional address family MVPN, and that's it. Without any additional configuration, we are ready to go. Of course, we need to configure the control plane towards the customers, but as you Daren mentioned, if we have already BGP for layer 3 VPN, extending that to MVPN is much more simpler.